selected 2 pieces of tube to be the pair for the Y frame rail, and what we're going to do is use these connecting plates to center punch and drill our holes on here, but to make sure that they're parallel first, we're going to use one of the tubes from the other pair and just sandwich it in here and make sure everything's all parallel to each other. And now that I know these are parallel, I can line this plate up where it's going to be and clamp it down.
And now we're going to use a transfer punch that fits in the hole of these plates to transfer a center line mark there to punch the holes.
And so I'm just going to tap all 4 of these holes and everything should be all lined up. We've got these 4 tubes drilled and they're all done now, so now it's time to move on to the rest of the tubes in the frame.
So we printed this little spacer here, or a template to drill the holes in these pipes at the 1 inch and 3 inch mark, and we're using a smaller transfer punch to transfer that. So we'll go ahead and slide this on the tubes. So one of the things when doing this, we put the spacer on flat on this side, you know, to give us the proper dimension from the end, but we're not going to do that on that end. You could, but we need these to be identical, so if there's any variation in our cut length, it could be wrong. So we're actually going to measure from that center part, scribe a line, and then we'll slide this on to our scribed line so we get them exactly the same distance.
So we've got all the tubes cut and most of the holes drilled for the whole frame. We haven't drilled the holes for the Y-axis rails yet where they bolt to the rest of the frame, because we need to decide between which pair, which one's going to be the top and the bottom. And in order to do that, we need to build the bearing carriers first and then see which one rides better on the tube. So we've got our Y-axis rail pairs picked. We know which one's going to be the top and the bottom, and now we know which one's the bottom. We can drill our holes so we can bolt the frame together. So to do this, I've got 6 of these tube spacers, and I'm going to insert into all the places where they need to go. And then I got 3 of my bolts that should bolt all 3 of these tubes together and make a nice, strong connection.
we cut off last time, we took a few minutes and we got the table painted up. We decided to go with red and black. We think it looks pretty sharp. And one of the first things we're gonna get to is a big mistake that everybody does on the standard. So what we need to do, guys, is we need to set the angle of this gantry support. It'd be the same thing on the standard version, is the angle of your X arm. If it's pointing down, pointing up, not pointing in the right direction, we need to level that thing. So we're gonna cover that today. So on this one, we need to have, we're using a straight edge. We could use the gantry, but it's gonna be easier for the video. So they need to be parallel along here with the straight edge from side to side. And if Jackson comes and zooms in, we're gonna see that we're really not very parallel. So I got the straight edge up here, and if we can see, we've got a little bit of a gap there, touching here, but we've got a gap. If I measure that with a feeler gauge, I got 2 of them there, it's amounting to about 1.1 millimeters. So we've got to make that level so when we bolt on the gantry, it's not putting stress on the bearings. So what a lot of people have done in the original plan to level their X-axis arm, they start adjusting the set screws on the bearings. That's completely the wrong situation. These set screws are supposed to be adjusted so you get a nice smooth run and no play, no slop. In order to get this level, we're going to loosen these 4 bolts and rock the center tube. These bearing blocks won't move, only this will. So we're gonna get these loosened up and we'll rock this into place. So I got them loosened up, guys. What I did is I loosened these 3 quite a bit and the same corresponding 3 on the back side. The 4th bolt I just cracked so I can lose. So I got a little bit of tension on that 4th bolt. It's gonna allow me to rock this at a pivot point on this bolt back here. Set this down, give it a little bit of a rock. And look at that, tight as a, doesn't fit in anywhere. Got it perfect. So probably one of the most difficult things about assembling the XL is making sure these tubes are parallel. We took a long time squaring this up when we did these corner reinforcements. So we're gonna take a look at this now. We're gonna measure across here. We're gonna come to the end here, Jackson. Take a look what we got. Where are we at? 62.25, and maybe just a line, just the width of a line over a quarter. Something like that. So yeah. We're moving down to the other end. Okay. Oh. Now let's see where we're at, Jackson. So 62 and just, can you tell any difference? No. Yeah, so we did a real good job. We took time making sure this is square. So we're gonna go ahead and get this X-axis rail mounted up. We're gonna put the X-axis on here, and we're gonna move forward with assembling the X gantry and start getting the motors put on. Well, we got the control panel built. We wanted to give you a good view of this before we install it in the box. We also wanted to test it. We've got the new ESP32 controller that we've started to switch our units over to. We've updated all the drivers for a more powerful, better profile driver, and we've gone to a higher voltage power supply that's going to give us a tremendous increase in motor output compared to the current setup on the Gen 2 model. So those upgrades we have going on in the machine. We also have an opto isolation bank. We'll get into that in a future video what that's for, but hook this up and we're going to do testing. We're going to test the motors, make sure they're working before we drop it all in the box. Hey guys, we got this powered up. We're going to do a little test here. This is kind of a test. Don't try it at home, but we just want to show you the increased torque, unscientifically, the increased torque of the motors with the higher voltage power supply and the improved drivers. So Jackson's going to move the gantry, and I'm going to see if I can stop it. I think we're doing pretty good, guys. So we're going to go ahead and get the micro switch mounted for the end stop and the auto squaring on the y-axis. So we're working on this side. We're going to pull the y-axis all the way back till the bearing block's hitting on these Y connection plates. So we're going to hard stop it against that. We're going to take the recommended screw. We're going to screw the jam nut on. We're going to screw it all the way in to start with. And then this activation, 3D printed activation bracket is going to mount right into the bearing block. So we're going to set it on there. We're going to use our screws. It's going to screw right into our holes on our bearing block. And these don't have to be very tight, just got to get snug because all they're going to do is hold that bracket on. So now we're going to take our switch and we're going to try and hit this part of the screw right on the black switch. So I'm just going to take a cutter and I'm going to cut part of our wing off. So we're going to set that on this switch in this location. I'm going to move it forward to activate the switch, and then I'm going to try and center punch this all at the same time. Get both holes. Looks like I got them pretty good. We're going to go ahead and push this out of the way a little bit, get these drilled. So we're going to go ahead and get these tapped. A little bit of a tap magic on them. You're barely going to activate as it's hitting that, which is what we want, because this is ultimately going to get screwed out a ways. We'll go through that. We'll go ahead and get the other switches mounted. So we got all our limit switch cables made, and we just put the aviation connector on it and a couple of female spade terminals on the end. So we'll get these hooked up. We've got them all labeled where they go. This one's short because it goes to our Y1. We're going to take the black wires and we're going to hook it to common. And then we're going to take the red wires on all of them and hook them up to the normally closed. Got everything wired up. We got the auto square ready to test. I'm going to move this back a little bit, then I'm going to make it out of whack. So you can see we're about 8 inches and about 3 inches. So we're going to see if our machine squares up. Got the homing on the Z. It's going to do a hard stop, come back, hard stop over here, and then it'll do a light stop and re-square. And now it's all squared up.
Okay, so we're gonna do the very first cut job on this machine. We've got water in our water pan. We've got a piece of 1/8 inch metal, and what we're gonna do is we're gonna cut just a triangle to make sure our squareness is set. So the first thing we're gonna do is actually hone the machine to square it off as it is now. So not a bad cut actually a really good cut. Not much slag. So we're gonna take it to a square and make sure that this triangle, this angle right here is actually square. So I've got the triangle cleaned up and I'm gonna put it up to the square, and you can see that there is just a little bit of a gap there on the top. So I'm gonna have to adjust the squaring switches on the gantry, and we're going to try that again. So I've got the triangle here. We can push it up to our square. Now we cut it. And it does not look like there's any gaps at all in that. Maybe just a little bit of gaps from the just the not perfectly smooth edge that the plasma cutter leaves, but when I push this up to the square, it looks pretty dead even. So we're gonna call that good.
We've got the XL done, the first version of it, and today we're going to be working on doing our first big project with the XL. So we've got an interesting little build we're going to do. We hope it works out. We're going to cut out 5 pieces and then hook it all together without welding, and it's going to be an interesting little project for us. We hope it turns out well. Well, the first cut didn't work worth shit. In our excitement to get this running, we forgot to hook up the ground clamp. So here we go, round 2. Those are tapered a little bit, so the farther they go down, the tighter they get. Jackson, give them a little tap with a hammer. That's good. That's good. How sturdy is it?
Maybe it's not on level ground, but like the thing ain't moving at all. Yeah, it's not moving here.
Well, there you go, guys. There's the JD's Garage fire pit.